Hi everyone, in this video tutorial we're going to be going over functional group priorities and functional endings. So remember, it can be the case that an organic molecule may contain multiple functional groups, and remember these functional groups are chemical motifs with distinct reactivity, which is why it's important to denote in a molecule what type of motifs we have to get a sense of the reactivity, right? And then each functional group has to be identified in an IUPAC name. And it's the case that there actually is a hierarchy to the priorities of these functional groups. They don't all have the same functional group, and there are certain functional groups with higher priority and would get the preference for that functional ending component at the end of the name. Okay, so check this out. This is something you should have committed to memory, and in Orga 1, you might only cover nomenclature of alcohols, amines, alkenes, alkynes, and alkanes, as well as being able to name ether and alkyl halide substituents. So just for right now, commit those to memory, but you may have to acknowledge later in organic chemistry that there are higher priority functional groups like carboxylic acids or amides or aldehydes, okay? Now, the idea is that if a molecule was just a straight chain hydrocarbon, then the highest priority functional group is just an alkane, and the ending of the name would get the ane ending. So here you have 1, 2, 3, 4, 5, 6 carbons. So here we would say this is hexane. We have our alkyl prefix denoting the length of the chain and the functional ending. However, if you had something like this, we have 1, 2, 3, 4, 5 carbons. We would name this pentan-1-all. Now, there is an alcohol, and notice how the alcohol has a higher priority functional ending than the alkane. So the ending of the name changes. Here we use the all suffix name to denote the alcohol. And notice that there's also a locant here that denotes where the alcohol is on our 5-membered chain. So this comparison here between our hexane and our pentan-1-all is to help you see essentially that we have to acknowledge any other functional groups present and know the relative functional group priorities so that we can correctly give the appropriate functional group ending, that suffix name. Okay? Now, if you had a higher priority functional group present, like carboxylic acid, and you also had an alcohol here, the alcohol just becomes a substituent, and this would get the functional ending for the name. So to just illustrate that real quick for you, we would say here that there are only 2 carbons, and the highest priority functional group is a carboxylic acid. And at the 2 position, we have an alcohol substituent. And when a functional group is a substituent, we will use the prefix name as opposed to the suffix name. Notice for the alcohol that is hydroxy. So when building this name, we would say 2-hydroxy ethanoic acid. And that oic acid ending is the suffix functional group ending for the carboxylic acid because it is the highest priority. It gets that functional group ending. And the prefix, the alkyl prefix eth, represents that there are only 2 carbons in the molecule. And again, here the alcohol was a substituent named in a molecule that had a higher priority functional group, and we used the prefix name for the alcohol to denote its presence, the prefix name hydroxy. So I really want to encourage you to kind of start committing this to memory. Be familiar with the suffix names, okay? And again, you use those when that functional group is the highest priority functional group. However, if it's not, like in our example above, then you use the prefix name and you name that functional group as a substituent of the molecule which possesses a higher priority functional